Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math-based, of course, and as always, it is an honor and a privilege to be serving you, as it is every day here on my YouTube channel. So kids, come on and step into my virtual classroom here. I got something I want to recap with you. Since the beginning of January, I've been doing no videos outside of systems of equations or systems of inequalities, except for one video on just inequalities only. But it led into systems, of course. So this is going to be an overall review of all the stuff I've been doing there. And keeping in mind that when we started the systems of equation stuff, it was the substitution method, elimination method, graphing, things like that. I did not do any videos in the past, I'm counting the weeks here, about 7 weeks, focusing anything on setting up word problems from systems of equations. But my last video was just on setting up word problems from systems of inequalities that have a very similar ilk to it. Now, if you haven't learned setting up systems of equations to then solve, there's an old video that I have, not old, but older, from the end of last year, October, September, or something like that. It's titled Translating Situations into Equations. So if you want to learn any of the things that I'm about to do now, I think I have about 21 or so practice problems reviewing this stuff. And if you have any questions on how to do any of the stuff I'm about to do here, I do encourage that you go back to some of my other videos where I teach it a little bit more, because this is going to be less about the teaching and a little more about the how to do. Like I said, 20-ish practice problems here. Actually, I'm half lying. I think some of them are a little more review of other things, because it's for my students who are going to be taking a test. So I think once I hit about question 16 or 17 or so, I think it ends the official what I'm doing there. But just make sure you understand that I'm going to be going through the problems a little more than teaching how to do it. If you have a question on how to do it, refer to some of the other videos, or hopefully you get enough insight from what I say on it, but I won't pause too much and say this is how you do it. I hope that makes sense. All right, without further ado, let's go ahead and get started. And we are going to be starting here with question number 1. Solve the system algebraically, verify your solution by graphing both lines and finding the point of intersection. I do want to let you guys know, actually, before I do officially start, is that the way that these problems are really designed, it's going to be starting only systems of equations, no inequalities, just systems of equations. This is the only one that's non-word problem based right here. And I do want to let you know that these problems are built toward progressing you from easier to harder, or asking you to do less to asking you to do more. As in, I'm not going to give you a word problem right now and say, write the equations, solve it, interpret it, define variables, all that. That'll be saved more to the end. Let's go back to this problem, because this problem is not a word problem, and that's what makes this let's shrink me a little. That's what makes this one a little easier than the rest of them. So this is kind of a review as well. Okay, so let's go ahead and get started with this problem. A lot of ways to solve this one. We can use substitution or elimination. It'll probably take the same-ish amount of steps. If I use substitution for here, I would maybe take this bottom equation here, and I'd get y by itself by adding 2x to both sides, like that. And then I take the 2x minus 6, and I substitute it in for y in the other equation. So in the other equation, I'll have something that says 3x plus, and then 2x minus 6 equals 9. Combine like terms, add 6 to both sides, and then divide both sides by 5. I get x equals 3. I'm going to take 3, and I can then substitute it into this equation back up here that we just had and solve for y. Y equals 2 times 3 minus 6, which is 6 minus 6, and that is 0. So that's that's solving algebraically by using substitution. That answer is 3, 0 right there. I will substitute, or I keep saying substitute. I will solve using elimination, the elimination method now, and in doing so, I'm going to take the bottom equation, say, and multiply everything by -1. I'm doing this because then I can go ahead and get y canceled, eliminated, on top and bottom in a brand new equation when I add these things up. When I multiply the bottom equation by -1, I basically switch all the signs on the bottom, or on the second equation. And I'm going to add everything, and I get 5x plus 0 there equals 15, and you get x equals 3. You can substitute x equals 3 into one of these equations, then solve for y. You get y equals 0, and we get the same answer. I'm not going to do that part again. So that is the answer. We can go one way or the other. You might have said, hey, elimination looks faster, but again, you had to substitute 3 back into an equation to finish, and y isn't yet by itself into any equation that you're doing this with, so it would take a couple more steps. Now, we're going to verify all this by graphing these two equations as well, and That's where substitution method was kind of actually, it's not substitution method. That's where getting y by itself using the substitution method was actually very helpful in what I need to do here. If I don't like my hide and divide solving with intercepts, I can use my slope-intercept form of this guy right here, y equals 2x minus 6, and I can go ahead and graph that by from negative 6, I rise 2, run 1, and I plot points until I connect all these dots here to make one nice long line. So let's go ahead and put arrows on these guys right here. Let's make it that nice dark blue, and I'm going to go and connect that. All right, that's this line right here. If I'm going to do the top line, and I'll do it, I guess, in green, because that's kind of what we have, I'm going to just do them by the intercepts this time. Hide and divide. If y equals 0, 3x equals 9, so x equals 3. And then y-intercept, hide and divide, set x equal to 0, y equals 9. So 0, 9, and 3, 0 give me those points right there and there. You can see that's where it crosses at, that 3, 0 that we've been talking about, and that actually ends up being the solution set. We are just verifying it through this graph. So we have then verified that, yep, that thing crosses through, not perfect, but that thing crosses through right there. Excuse me. And we have found our solution set. Remember, the point of intersection for two lines is going to be the solution set there. That's what we found when we did this, finding x and y. That's why we have to write it as an ordered pair. Okay, number 2. Identify the system of equations that properly matches the following scenario, just circle one, then solve the equation you circled using any method. So it's going to give you the system. You got to select which one's true, but it's going to give you the system and then solve it and answer the questions based on this. A father is 3 times his daughter's age. He is also 28 years older than her. Let F and D be the father's and daughter's ages in years, respectively. So F is not female and D is not dad. Make sure you know that, all right? F is father, D is daughter. I might mess it up a couple times. I'm just saying make sure you know. So we're not using X and Y. All right, F is father, right? Father, daughter. A, if we take 3 times the father's age, would that equal the daughter's age? I don't think that makes enough sense to say 3 times the father's age is the daughter's age. The father should be older. The father is 3 times the daughter's age, but that means we got to triple the daughter's age, not the father's age. That doesn't seem to make sense there. So that means that C doesn't make sense either because we have 3F equals D. So it's got to be one of these two. Now, which one's correct among B and D? We have the father's age equals the daughter's age plus 28. I think that sounds right. And I think I'll go and take that one right there. The opposite here is the daughter's age is the father's age plus 28. Now, see, if the father is 40 years old or 50 years old, we don't add 28 to that number to make the daughter's age. We would subtract. So it looks like it's going to be B. Now, I am going to solve using B, but let's say that you accidentally did D. When you solve it, what's likely going to happen is either one of two things. One, or both. One, you will get a daughter's age that is older than the father. Or 2, you might even get, let me make myself big for a second. 2, you might even get a negative age out. Even if the father's older than daughter, let's say the father becomes 5 years old and the daughter becomes negative 20 years old. Well, the father's older, but you can't have a negative age, okay? So good news is, even if you select a wrong answer, something will go wrong in the answer for you to say, wait, that's not right. So D will be wrong eventually for whatever reason it becomes, and B ends up being the only correct answer when it comes to the logic of what we end up writing out. Okay, let's go and solve this thing. Now, in order to solve it, I'm seeing a little substitution method here. I want to place maybe 3D in for F in the other equation, because remember 3D equals F. So I can make an equation now that says 3D equals D plus 28. If I subtract D from both sides and then divide both sides by 2, I get D equals 14. That's the daughter's age. And by the way, I'm not going to answer this thing as an ordered pair anymore. This is a word problem, and I'm going to write it as a sentence. The daughter is 14 years old. So how old is the father? We have 2 different options that we can do. We can either say the father is triple the daughter's age, which is going to be 42. Or you could have used the other equation. The daughter is 28. I don't know why I put parentheses. The father is 28 years older than the daughter. That was hard for me to say the sentence, which is still 42. So no matter what, we get 42 years old for the father, which seems to satisfy both sets there. And again, if I flip-flop something here, I'd either get negative values or I'd get the daughter being older, or both. Neither are possible. And I don't know why I just thought of this one thing here, but I was just thinking of a song from a movie called The Stupids that's titled I'm My Own Grandpa. It's really stupid, but logically is actually possible to have happen. It's possible for you to be your own grandpa. It doesn't involve things that I would recommend. Let's move on. Numbers 3 through 5 actually, all based on the same question, if you will, the same situation. One night, the manager of a shoe store evaluates the receipts of the previous week's sales. 240 pairs of two different styles of shoes, Adidas and Nike, were sold. Adidas sold for $66.95 and Nike sold for $84.95. The total receipts were $17,652, meaning that's how much they added up to. The cash register that was supposed to record the number of each type of shoe malfunctioned. So we don't know how much of each type of shoe there is. That's important for number 3. Identify the variables in the scenario. If we were going to define X and Y as something for our unknowns for what to solve for, what would they be? Would it possibly be the number of pairs of Adidas and number of pairs of Nike sold? I'd say that's a good possibility because we don't know how many of each were sold. We know how many total were, but not each. So I'm going to say it could be A. It probably is A. In fact, I kind of know that it's A. But let's move on to the others to make sure that we aren't incorrect on the other ones. The number of Adidas and Nike pairs sold and the cost of all the shoes. See, we know these bits of information. I know this is 240. And cost of all the shoes, if it's one per, this or the 17,652, we know these numbers. I don't need variables for those. I'm going to use these in my equations with my variables. So it's definitely not that one. That's definitely out. The cost of each pair of Adidas, the cost of each pair of Nike. Again, we know that. It's right here. Again, not a variable. We're going to use that information with our variables to do something else. The number of sales receipts and the amount of money in the register. Well, I don't know if the amount of money in the register is this or not. And the number of sales receipts might be equivalent to the 240 pairs of shoes, whatever, but that's not information that we need. The each type of shoe thing malfunction, this is not the information that we need here. This is bogus, if you will. It's going to be A. We're going to let X equal the number of pairs of Adidas sold and the number of pairs, and Y equal the number of pairs of Nike sold. Okay, the following system models the situation. So in this situation, here's why they said 240 pairs of Nike was sold. X plus Y, or of Adidas and Nike were sold. X plus Y equals 240. And then here we talk about the money here with 66.95 X plus 84.95 Y equals 17,652. What does 240 represent in the context of the situation? Well, as it said in the situation, as it kind of says in this equation, it's not money, it's the total number of pairs of shoes sold, both from Adidas and Nike. All of it, the total number, not just from one or from the other. The total number of pairs of shoes sold in general. The top equation is about shoes amount. The bottom equation is about dollars amount. Remember, 17,652 was dollars. Number 5, what does 84.95Y represent in the context of the situation? In context of the situation. Be careful on this thing, because 84.95 is the cost of each pair of Nike shoe, brand shoe. Okay? But it doesn't say 84.95. It says 84.95Y, which means 84.95 times Y, if you will. Y represents the number of pairs of Nike sold. So if we're going to multiply the cost of each pair of Nike sold by the number of pairs of Nike sold, let's say, for argument's sake, let's say that number was 100. When you multiply 84.95 by 100, the decimal just shifts 2 over, but you get $8,495, which, by the way, is still within the realm of this. It's very possible that could be the answer. And also, by the way, we're not solving this answer. We defined the variables, the equation stuff set up for us so we can determine what these things mean. So the next time that we have to set up an equation, we'll know how to do it based off the information. Anyway, if it was 100, it could still fit. The point is, this is number of pairs of shoes. This is cost of each pair. This is the total amount of money spent or made, the total amount of money from selling those pairs. This 84.95y is the total. And remember, the 100 was an example. It's not the real answer, but 84.95y, y could be 100. And if it is, we see what that number represents. It is the total, what do I want to say, cost, the total amount of money, I'll put in dollars, made from selling Y pairs of Nike shoes. All right. Maybe you don't have to go that overzealous, but you do have to say something about dollars and Nike. But it's not cost per, it's cost of all. You don't have to say Y, you could say all pairs, and I think that could fly. All right, that's numbers 3 through 5, and that takes care of that. Now, not asked to solve. Eventually, you will be asked to solve, and at some point, you might need a calculator. In this one, we're going to refrain. All right, number 6. Define variables and set up a system of equations that models the following situation, but don't solve. And again, don't solve. A lot of white space. Let's make it big. Don't solve here. So set it up. All right. Now, there is an answer to these. If you want to practice by solving, go ahead, but you won't see it in my video. You and your party dine at In-N-Out Burger. Everybody agrees to only purchase quantities of double-double burgers and or fries. In the order, a total of 24 double-doubles and 12 orders of fries were placed. The overall cost was $111.12. You recall the last time you bought a double-double and an order of fries, the overall cost was $5.50. What is the cost of one of each? All right, fun fact, this is an older problem I've done way in the past. I probably made this problem about 4 or so years ago, 3-4 years ago. So these were actually realistic numbers. I'm not saying I realistically did this situation, but these numbers plus tax were actually the amounts. So you could find out what they were then. But of course, inflation and cost of meat has risen and things like that. It is probably larger now, but all this is with tax included in this problem. Okay, just so we're understanding, the double-double has nothing to do with numbers. Hopefully you get that. Like double-double doesn't mean 2 times 2 and that's 4 and we do something. Oh, you can't see that. It doesn't mean like 2 times 2, which is 4, and we're not doing something with that. Double-double is just the burger type. That means 2 meat, 2 cheese. And that's what I had in the original problem, but it got a little too, we were saying more than we had to. So anyway, so for double-double burgers, again, we bought 24 of them and 12 orders of fries. And the last time you bought a single double-double and order of fries, and it was $5.50. What is the cost of one of each? We don't know how much a double-double costs. We don't know how much an order of fries costs. And this is regular, non-animal style fries. We could use X and Y. I'm going to go ahead and use D and F for double-double and order fries, or dad and female, or daughter and father. A lot of D's and F's used here. Let D equal the cost, and it's not the number of double-doubles. Remember that. We know how many. The cost of one double-double. I'll put DBL. I think they say something like this in the receipts. Double-double. So, if that helps. F is the cost of one order of fries. Now again, not asked to solve. Why am I not asking to solve? Good question. For one, as this is building for my students toward a test, I'm asking a lot of different questions on this thing, and it takes up time. It's basically the big one. It takes up time. 2, I'm trying to, again, this thing is built to have you progress through what's asking less of you and then later asking more of you. So this time I'm just asking you to set up the equations with the stuff. I think the next few problems, though, we are actually setting up and solving. All right, let's make 2 different equations. Let's do the easiest one first here, which is 1 double-double and 1 order of fries. Their cost each gives us $5.50. And then the other one down here, or up here, 24 double-doubles, so 24 of them times the cost of each, plus 12 order of fries times the cost of each, equals $111.12. The other reason I don't want to do these kinds of problems are a lot of different decimals, or makes the numbers bigger. I think we do have a money problem later that we will be using things like decimals and such, but just avoiding it from here. But yeah, just building as we go. I didn't want to spend too much time on too many problems. If you do solve it, I don't remember the answer. This is a 4-year-old problem. I don't remember the answer, and I couldn't tell you the cost, and I don't have it memorized. I don't know, maybe around $3.70 for double-double. I can't actually remember, but you can solve it and figure it out. I'm actually going to move on from here, though, so that's it. All right, so the rest of the problems from here when it comes to systems of equations are going to be actually solving them, setting them up and solving them. There are 3 more here, and then I have 1 more that involves kind of a bigger graph thing that you'll see. All right, for each situation number 7 through 9, set up a system of equations and solve algebraically, put answers into context. Solving algebraically means 2 things. Number 1, don't graph it. Number 2, don't guess and check. So use the substitution or elimination method, and that's all that means. Okay, the sum of 2 numbers is 77, and their difference is 21. Find the 2 values. Now, thankfully for you, again, for the sake of time and not messing things up and all that kind of stuff, I'm defining the variables for you on all of these. So let's let x equal the larger value and y equal the smaller value. And there's a reason why we're differentiating between what's larger and what's smaller, just like the father and daughter in ages. You'll see what I mean when I start writing it. So let's set up the equation, and we will solve the system, and we'll solve. The sum of 2 numbers is 77. When I add the larger and smaller value together, I get 77. And then the difference is 21. When I subtract the smaller value from the larger value, I get 21. And here's why larger and smaller matters and makes sense. I know that when I solve for x, I better get a larger answer. If that does make sense there, I should be getting a larger answer than the other one. Now this one is pretty straightforward as far as solving because y's are opposite of each other. Right now, if I add and use elimination, I get 2x. Please don't just call that x. X plus x is 2x. And then the y's do cancel. Y minus y is 0 equals, and then 77 plus 21 is 98. So divide both sides by 2, you get x equals 49. So there is that guy. Now the y value, let's go and substitute in somewhere. How about the top equation? 49 plus y equals 77. Subtract 49 from both sides. We're going to get y equals. If you don't know how to do this one in your head, here's what I would do. 49 is really close to 50. It's 1 less than 50. Let's do 77 minus 50. Well, that's 27. So 77 minus 49, if 49 is 1 less than 50, it's 1 more than 77 minus 50 because I'm subtracting less. You get it? So 77 minus 49 is 77 minus 50 is 27. 77 minus 49 is 28. And it shouldn't take that long to say all that when you're doing it. I'm just explaining how you can do it fast without writing anything or using a calculator. I'm not done answering this question, though, because as you could tell from the father-daughter problem, we answered it in a sentence. And that's why the father-daughter one was there to begin with. So the larger number is 49. And the smaller number is 28. And again, it's not just one number is this, the other number is that. Make sure that you did set it up properly. And if you didn't set it up properly, or if you didn't use elimination properly, you might have accidentally, unfortunately, gotten a negative number as one of your answers. And that's not to say you can't. That's not to say you can't, but you got to make sure that the sum and difference all do align that way. And they might not, because then that means you got a different answer than me, and this is the only correct answer. Okay, on a test consisting of multiple choice and free response portions, so MC is going to stand for multiple choice, FR free response. One student got 22 multiple choice questions correct and 4 free response questions correct for a total of 84 points. And another student got 18 multiple choice and 2 free response questions correct for a total of 56 points. If this is out of 100, they failed. Yeah, this person got a B. How many points is each portion worth, the multiple choice and free response? Now, interestingly enough, just to make myself clear, we do not have or know, sorry, I don't like the white space. We do not have or know how many multiple choice and free response questions are on the test. And I get it, that is an unknown. However, we know nothing, absolutely nothing about the value of multiple choice and free response as it stands. Therefore, when these variables are defined, they're not total number of multiple choice and free response questions. By the way, we wouldn't have enough information for that anyway. We just wouldn't, unless we can assume this is all out of 100 points, in which case we could do something with that at some point if you want to. But I'm not going to. Let's go ahead and get started. M is the point value of each multiple choice question. F is the point value of each free response question. We have enough information to be able to get the point value of each, how much each question is worth based on this information. And the equations will look eerily similar as far as what I do. If you multiply 22 multiple questions correct times the value of each multiple choice question, and add that with 4 correct free response questions times the value of each free response, assuming no partial credit allowed. That's a total of 84 points. The number of points made from multiple choice questions answered correctly, the number of points made from free response answers questions correctly equals 84 points total. Now that's one student, and the other student has the other bit. 18m plus 2f equals 56. Okay, that's the system. So we got to go ahead and solve this guy here. There are a lot of different options that could be advised. I'm going to go ahead and do some things just to explore this a little bit. I see a lot of even numbers. I can divide everything by 2 in both equations and make this even a little better for myself if I wanted to. Should I go that boisterous? No, you know what? I think if I divide by 2 here already, then that would give me 2f on here, which is good because I can then cancel the f's pretty easily. But I don't just want to divide by 2. I'm going to divide by -2. That way when I go ahead and write this thing out, and let me just get rid of this so you don't really see it anymore. I can see it, but I want you to know that I'm not using it in my elimination. I'm using the rewritten one I'm about to write. But that way, when I make it negative, they'll actually cancel out right when I add, because I have 2f and a -2f. All right, 22m divided by -2 is -11m. 4f divided by -2 is -2f. And 84 divided by -2 is -42. Okay, so now when I add, everything will be kind of as I need them to. The f's cancel. 18m minus 11m is 7m. And you might wonder, you might say, Mr. Robinson, you just said when you add. Why did you subtract? I'm adding this with the negative this. 18m plus -11m becomes subtraction. That's why I'm saying this has to be negative, so that way we can add. All the signs are what they are. 56 minus 2 is 14, and divide everything by 7 there, we get m equals 2. Now that will answer our question as far as multiple choice value. The value of each multiple choice question is 2 points. All right. Free response. Let's substitute it into, how about this equation right here? 18 times 2 plus 2f equals 56. That's 36 plus 2f equals 56. Subtract 36 from both sides. 2f equals 20. Divide both sides by 2, f equals 10. All right, we have solved that. And once again, we are not yet finished. I got to shrink myself now. We are not yet finished answering the question because we have to state it in a sentence. Now, I'll let you know right now that it's a bit, I don't want to say controversial, but it's a bit up for debate whether or not I do actually have to answer this. If I did define the variables, if I said m is the point value of each, and if I did say m equals 2, then 2 is the point value of each for multiple choice. So do I have to? I'm still going to say yes, and the main reason is because you want to make sure that you're answering the question being asked. Okay? That you know you're answering the question being asked. And the only reason I'm saying that is, what if on that daughter-father question, they only asked for the father's age? Okay? If they ask for just the father's age here, and I'm trying to say a sentence as I'm typing a different sentence. We'll see if I can do this. If I only ask for the father's age, then I don't need to solve for D for the daughter's age. I just need to answer the father's one. So when I say F equals 42, then that's enough for me. I don't need to do, am I writing? I don't know if I'm writing this correctly. I don't need to solve for D for daughter's age. So I'm just making sure that I'm answering the question. And now when I write the sentence, I am answering the question. Each multiple choice question is worth 2 points. Each free response question is worth 10 points. So maybe it's possible, and it's not asking you this, and I don't know if it's enough information. It's entirely possible that this could have been a question where it says something like, maybe there were 25 multiple choice questions, and maybe there were 5 free response questions, and that would give you 100 points total. I don't know. There's nothing like that on here. Okay. Last one, number 9. This is that money question. Like I said, we're going to have to do a little more as far as calculating because the decimals or the larger numbers. We've seen these problems a couple times before. Cassie has a total of 110 coins in her piggy bank. All the coins are quarters and dimes. The coins have a total value of $20.30. How many quarters and how many dimes are in the piggy bank? Okay, we don't know how many of each. So let Q equal Cassie's total number of quarters, D equal Cassie's total number of dimes here. Now when you add the number of quarters, let me use a different color. When we add the number of quarters with the number of dimes, we get a total of, and don't say the money here, we get a total of 110 coins. This is a coins equation. I'm going to make another equation that's based on the value of them. Now I'll let you know right now. On the last review video thing that I did, there was a word problem set up for us with this, or the equation was set up for us with this, and I explained away how everything worked. Now that we've talked about these several different times, I'm going to go right through it, and I'll say two different things I can do with it, one that I'll start with and that I'll transform it to. Total value is $20.30. How do we go ahead and make an equation that talks about quarters and dimes with that? Well, each quarter is 25 cents. That's its value. So if I multiply the value of each quarter by the number of quarters, then I get how much money I have in quarters. The problem with the 25 is I can't just write 25 because this unit is in dollars. This is $20.30. If I write 25 right here, that actually means $25 because this is dollars right here, 20. So I need to make sure it's a decimal. So it's, like that, maybe 0.25. When I multiply that by the number of quarters, and then dimes here is 0.10, multiply that by number of dimes there, I'm going to get total value of all my money. So that is my system right there. Now what I need to do, I need to solve, but one thing that could be helpful, and this is what a lot of people would agree with, is I could go ahead and take the decimals here and shift them 2 to the right. This is equivalent to multiplying by 100, the entire equation. What this allows me to do is rewrite this thing without decimals involved. So now I have 25Q plus 10D equals 2030. Another thing that we can do with this thing, or another way that you could have written this to begin with, is, see, this was a dollars equation up top. This guy right here was a dollars amount. That's a dollar sign. This one down here, 25, that's the number of cents. This is number of cents. This is number of cents. So you could write this out as a cents equation to begin with if you're going to use 25 and 10. Just make sure that the 2030 is not a decimal anymore. It's 2030 pennies. You know what I mean? So you could do that. All right, a lot of options I can do from here just to kind of show the whole rewriting both equations thing, especially if you don't like super large numbers to work with. I could divide everything by 5 here, and nothing would actually go wrong. I don't want to write the divided by on this side, though. Divided by 5. If I divide everything here by 5, I'm going to go ahead and get 5Q plus 2D equals, 406, I do believe. I hope I'm not wrong. That seems right. And now I can take this one here. Maybe I can just multiply everything by -2. So now when I take my 2 from my system, I'm going to go ahead and get a little bit of smaller numbers to work with, and I'm going to cancel out D. So -2Q minus 2D equals -220. Now, if this is your first time doing a problem like this, I would have instead just said, take this equation, multiply by -10. Be okay with that. And to cancel out D, I'm making my numbers smaller because I can. Look, it's because I can. So therefore I will. 5Q minus 2Q is 3Q. The D's cancel here. 2D minus 2D is 0D. And then 406 minus 220, 280 is 280. No, 180. 180. So 3Q equals 180, therefore Q equals 60. I'm really running out of room here. I'm just going to write what D equals based on my top equation. 60 plus D is 110. Subtract 60, you get D equals 50. So that's my answer set. My actual, the thing that I actually write, let's erase this last bit right here. Let's use a color I haven't used yet, such as green. And I'm going to say how many quarters and dimes Cassie has. Yes, this got a little overly complicated with all the different stuff that's written, but Cassie has a total of 60 quarters and 50 dimes. What do you know? There we go. 60 quarters and 50 dimes. That was solved using elimination. All these were really good elimination problems. You could use substitution on maybe one of these here, but you know what? Sometimes you just don't have to. Okay, I got one more systems of equations. Oh, I skipped a question. You know what? I'm going to pause my video for a second. Look, I went from 9 to 11. It looks like I didn't put a problem in here. This jumps into the inequalities next. I skipped to number 10. I'm going to go ahead and pause this, put it in my video, and you'll be back in 5 seconds, and you'll see it from there. All right, here we go. Okay, and I'm back. Miss me? All right, cool. Okay, so moving on. So here's that number 10 that I promised you, and when it comes to graphing, I'll go ahead and hide myself when need be. In fact, I don't need the graph right now. Why don't I make myself really big? Hello, I'm here. All right, number 10. 2 campgrounds rent a campsite for 1 night according to the following table. So if you have, now this could obviously expand. This is just, and so on and so forth. But here's just enough information for the table. Let's use it. Number of campers, 1, 2, or 3. If you're at campground A, it's going to cost you this much. Campground B, it's going to cost you this much. Why would I go to campground B? It looks like it costs more. Well, every time you increase the camper by 1, it seems to cost less over time, which means as we add to 4, 5, 6, etc., when is it going to, change things? Let's write a system of equations for the amounts charged by each campground. Let x represent the number of campers at each campground, and let's let y represent the total amount charged for 1 night rental. So here you go. These are 2 different y values that are going to be used. And we've done a problem like this before. It was like the tortoise and the hare, something like that. You plug in these values for x, you get these values for y. Then you plug in these values for x, you get these values for y. So I'll say this is y for campground A and y for campground B, just so you're understanding what the y's, how they're 2 different y things here. So we're going to make a campground A equation based on the amount of money you're going to spend here. And this has everything to do with a starting amount and a total rate, a rate per camper as you increase the number of campers. As we increase the number of campers by 1 here, we're adding $15 each time. Adding $15 each time. Now, it doesn't say 0 campers here and what would happen with 0 campers. Now, I want you to know that 0 campers is a theoretical thing here. It's not used to really make sense. Sorry, something popped up on my screen. Looks like storage sense got turned on my computer. I think I'm running out of memory because all the videos I record. Okay. The 0 campers thing is only theoretical. It's to help explain the equation that we have, but it's not going to make enough logical sense for our thing. So if that makes sense, we're not going to be renting at a campsite and not staying there and therefore maybe have to spend money, because I think that's going to happen on campground B. Campground A, if I subtracted $15, if I continued the rate backwards, if I take away a camper and I take away $15, that's going to be $0. So the starting value, the constant part, the part that builds up from this, is 0. So how do I write that equation? So 15 is like my slope, my rate. That's $15 per camper times the number of campers. I could put plus 0 here to just indicate that there's nothing added on top of that just for kind of renting the thing, but I'm not going to. Now I'm going to make a second equation here for campground B that shows us right here that we're adding $10 per additional camper. So that's going to be our rate, $10 per camper times the number of campers. But you'll notice here, if we had this constant amount, when I substitute 1, 2, and 3 into here, I'm not going to get 40, 50, 60. So that's where I need that kind of minus $10 for 0 campers would be $30. And it's not really $30. It's just a constant amount that when you camp here, there's $30 as a portion of what you're going to do, plus how many campers you have, including that first camper, right? The first camper actually cost you $10. So 10x, and there's this plus 30 right here. Okay, it's just this additional amount that is included in the set. Let me really quickly here. I said that I'm running out of memory, and I'm sure I am. I'm just going to go ahead and delete some of my older videos that I don't think I need, just in case I do run out of memory. So I'm going to do that right now. Sorry about this. Come on, recycle bin, empty. There we go. All right, hopefully I should be good. Okay, let's keep going here. These are the 2 equations. So part B says for how many campers do the campgrounds charge the same amount? What is the amount charged for that number of campers solved by graphing? So somewhere on that graph, let me show you that graph again. Let me take myself away actually. Somewhere on that graph here, we're going to find, if we graph these 2 lines, we're going to find out where they intersect. Okay, and if we find out where they intersect, then that's going to say the same number of campers for the same cost. So it's probably the thing where you can then find out like, oh, if I have 10 campers, then I should really do one versus the other. Or if I have 2 campers, clearly 2 campers, you should do A versus B. But at some point, B is a better value depending on the number of campers you have. So let's go ahead and, so I'm assuming campground B gets a lot of big parties, if you know what I mean. Okay, so campground A, y equals 15x plus 0. That means a y-intercept, let's use this in blue and this one in green. That means a y-intercept of 0, and I'm going to rise 15 and run 1. Now I'm not going to count 15 up, I'm actually going to find the number 15. Rise 15 and run 1 is a point like that one right there, and I keep rising and running. Now, I do want to let you know that this should, in theory, this should be what's called a discrete function. And I can't really fit another, but it keeps going. And in a discrete function, what happens is you don't connect the dots because you can't have half of a camper. That being said, when these 2 points intersect, they better intersect at integer values because, once again, you can't intersect at half a camper and say, oh, if you had 6.5 campers, well, you know, that's one's going to work. But I'm going to connect them anyway for the sake of what we've been doing recently and just talk about these as lines that are intersecting, especially since you probably aren't color coding yours. Okay, so understand that this should be a discrete function because we're talking about number of campers. And there's actually another word problem later that arguably should be discrete as well. However, it's going to be easier to read as a line, even though it wouldn't make sense fully as a line. All right, the other one is y equals 10x plus 30. So 30 is my y-intercept, and this time I'm going to rise 10 and run 1. So I go to 40 for that first camper. And we know the first few values anyway, by the way, 40, 50, 60 for the first few, but this should just continue. And this equation does explain that. And you notice how it gets closer and closer to this thing until, oh, look at that. That's where they intersected right there. And then it surpasses it to a better deal for campground B at that point. But let's go ahead and draw these. And they intersect right here at the point 6 for X and 90 for Y. Now that is our solution. Now put final solution in context and complete sentences. Maybe 1 or 2. It depends on how many sentences you kind of need. So I'm just going to go ahead and type it out here and say, because the question was how many campers do the campgrounds charge the same amount? The campgrounds would charge the same amount of, because I don't think I'm going to have enough room, $90 for 6 campers. Don't worry, I'm going to make that look a little cleaner here. Give me a moment. Okay. And not perfect. But the campgrounds would charge a total of $90 for 6. There we go, that's a little better. $90 for 6 campers. Okay, X was 6, or X was number of campers. If X equals 6, then Y would equal 90 in both of these, and that's where you'd be charging the same amount. And the graph shows that one here. So we didn't solve algebraically. We didn't use substitution or elimination, which actually, if I just did really quickly, let's substitute 15x in for this Y. 15x equals 10x plus 30. Subtract 10x, 5x equals 30, and you get, not Y, you get x equals 6. Substitute 6 for x in either of these, solve for y, like this bottom one. 10 times 6 plus 30 is 60 plus 30, which is 90. So, yep, that does seem to work out, that 90 and 6, or 690, and that does equal what it did right there. Okay, so, I guess I could have kept myself right here. But number of campers was down here, amount of dollars per campground was here. And again, probably shouldn't have been a continuous function. So drawing a line probably doesn't really make the most sense there, but the idea, again, just in place is we're just finding out where the two lines intersect, that's all. Okay. All right, that's it for systems of equations. Now we're going to go in systems of inequalities, first starting just by graphing a single inequality, and then from there afterward, we're going to be doing all of them as systems. I get to be big again, yay, hello. Actually, not too big. Let's go back to just kind of this size. Or how about, I have all these different options that I have. I can do whatever I want. 2x minus y is less than -1. Let's go ahead and graph this. I would not graph out a standard form because I don't want to divide 1 by 2. So I'm going to go ahead and get y by itself. And in doing so, it's going to say, if I subtract 2x from both sides, -y is less than -2x minus 1. I have to get y by itself. It can't say -y. So I'm going to divide everything by -1. Now, when you divide by a negative, two different things happen. Number one, the signs of all of your terms change. They change all from negative to all positive, like this. Number two, the inequality flips. when you multiply or divide by a negative, the inequality flips. I've talked about it before, not going to talk about it right now, but it does. So when you multiply or divide both sides of an inequality by a negative, the symbol flips. So we're going to graph y is greater than 2x plus 1. So I'm going to go ahead and plot the points starting at 1. I'm going to rise 2, run 1, give myself quite a few points here to draw a dotted line because it's greater than, not greater than or equal to. So I'm going to give myself, excuse me, a dotted blue line like that. That just means the dotted means that points on the boundary line do not count. They do not exist as solutions to my inequality, but greater than do. And when you're in slope-intercept form, when it's greater than, we shade above the line. So above the line is over here on this side. I'm just going to do a very quick rough shading. You can double check this in a lot of different ways. If I were to double check this, I like to plug in the point 0, 0, like this guy right here. Does 0, 0 satisfy this inequality? Now, if it did, then that means I shaded on the wrong side, because 0, 0 is on the underside. And if 0, 0 works, then all of these would work. But let's test 0, 0 and see if it works. Because if it doesn't work, that means I did shade on the correct side. Or it could mean your boundary line's wrong. So make sure you draw the boundary line correctly. But try it with the original, please. The main reason is because you don't know if you might have made mistakes leading into this. So let's test the original. 2 times 0 minus 0, that's 0. Is 0 less than negative 1? That answer is no, it's not. 0 is not less than negative 1. So 0, 0 fails, which means every point on this side fails. That means these points are not solutions to your inequality. These points are. If I test negative 3, 5, I will get a true statement out. I'm not going to, but that's how the shading for this one particular inequality works. Now, the rest of the problems here on out will be on systems of inequalities, so remember that. We're going to be graphing more than one inequality per graph as need be, but this is a first just set up and draw and graph. And remember, these will build up as we go as well. So this started with a single one, so let's look at the next one. Okay, so number 12, circle the letter for the system of inequalities that matches the following graph. Now this time it's drawn, and we just got to give the answer for this thing. Okay. All these have the same information, but the symbols are all different. You can see how this says greater than or equal to, less than, greater than, less than or equal to, less than or equal to, greater than, less than, greater than or equal to. You know, those change. Everything else is the same, which means this is your negative 1/2 x plus 2 line, and this is your negative 3x minus 3 line. Okay, so that's all the same. So A, B, C, and D are still open and up in the air for now. Okay, let's eliminate the easy part first. We have a dotted line, or let's eliminate the easy ones first that we know are not answers. We have the dotted line of negative 1/2 x plus 2. That means that that's not an or equal to. It's just the greater than or less than, depending on what it is. So we know it can't have an or equal to. So I know that C is out, and I know that D is out. So it's between A and B. Okay, the second part about this is the shaded region is the intersection of the previous shaded bits for the other guys. What I mean by that is they erased the other parts where the shaded regions do not intersect. Now, if we're shading between these two right here, that would mean that for this line, and I'm just going to kind of use a different color for a moment, for this line right here, that shading is above the line. So if I continued to shade above the line, that would include this up here, okay? I'm just showing you what the original shading would have looked like, if that makes sense, and also to make sense of the answer. Underneath the dotted line, though, means underneath the dotted line like this. So this is what the original shading would have looked like, and the intersection of blue and green is what's left over, and that's what they're showing you, the actual systems of the solution. So I'm going to go ahead and erase those, but keep in mind we are above the solid negative 3x minus 3, and we are below the negative 1/2 x plus 2. So which one is above the negative 3x minus 3? That looks like it's going to be this one here when you're greater than or equal to. But when you're greater than, you shade above. And this one's less than, we shade below. So I believe that it's A. B, we'd be shading below negative 3x minus 3 like this, and above negative 1/2 x plus 2 like this, and this would have been our answer right here. And that's not what we're doing. We're not doing that, so it's not B. It's going to be A. All right, so that's the shading above and below, once again, in a system, and these intersecting points are where we do the shading. So here we go, number 13. Number 13, we are going to complete the graph. So these are kind of already graphed. The boundary lines are graphed, and we got to shade one of these four regions as well. But we also have to determine whether the lines will be solid or dashed for these. So y is greater than negative 2x minus 3, and y is less than or equal to 3x plus 2, both in slope-intercept form. That's cool. Negative 2x minus 3 is the negative slope line. It's going to be this one right here. So to start off, it does say greater than. Greater than, besides shading above, is also a solid line. Okay, it's also a solid line. I just said solid. What do I mean? It's a dotted line. So I'm going to draw it in blue. And I'm going to do dotted. Oh, I'm already ready. Dotted in blue, it's going to be looking like this. That's how I'm going to fill that guy out. So I don't actually have to graph this thing. You know, it's kind of done for me. I just got to figure out what it does there. Now I do shade above. And if you want to start with the shading above, you could, but I'd be shading right here if I did. I'm not going to. I'm just going to shade the final region when I'm done. So all I know right now is the final answer is going to be shading in B or C. Notice how I'm shading in both B and C, or I'm simulating it. That's because these are the solutions for just the blue line, or just the top inequality. A and D are already out. I know this right now. All right, y is less than or equal to 3x plus 2. So this time less than or equal to means solid line and shading underneath. Okay, so solid line, I'm doing it in green, and shading underneath. So solid line right here, that's how you're going to draw that. Now shading underneath is going to be on this side right here, shading underneath, where I'd be in either the C realm or the D realm right here, C or D, which means A and B don't work here. So A is out for green, B is out for green. That means that only C remains as the shaded portion. You know, what's below the green and above the blue? Option C, which by the way includes 0, 0. I'm going to double check that with you afterward. But you don't have to shade the two intersecting regions first and then find the intersecting bit. You can just determine what it is beforehand if you'd like to, and then draw it out. If you really want to double check, that's probably wise to do. But remember, we're above one and below the other because we are in slope-intercept form, we are comparing y to those sets. Now, when I test 0, 0, this should actually work for both of them. So let's see if 0, 0 does work. 0, that's for y, and 0 for x. 0 is greater than negative 2 times 0 minus 3. That 0 is greater than negative 3. That is a true statement. That does check out for blue. For green, 0 is less than or equal to 3 times 0 plus 2. 0 is less than or equal to 2. It's not equal to 2, but it's less than 2, and that checks out as well. So the region that includes 0, 0 is also the region that works for this, and that's what you had to do. Graph the system, do all that stuff. Okay. All right. Number 14. We have a system. Now we're going to graph it completely. So see how it kind of built as you went? Now we're going to graph both completely, and we're going to talk about whether these 2 points satisfy the stuff or not. And I crossed out the above system because I had to move this over on the page to fit it. It's not the above system. It's the leftward system. It's the system over here. All right, graph the below system of inequalities. So this top one, I have slope-intercept form. Y is less than or equal to 2/3 x plus 4. I'm going to start at 4 right here, and I'm going to rise 2, run 3. You know the drill. Plot the points. To talk about this a little further, because it's less than or equal to, it will be a solid line, and I will be shading underneath it. Okay. Now, just like last time, I'm actually not going to shade until the very end. I think it's just takes a little less time on my end. And I've complained about it before, but the tip of my little thing, I have to change it out a lot if I do a little too much drawing on it. So remember, we will be shading underneath. Negative 4x plus y is greater than or equal to negative 6. I don't want to use my standard form hide and divide method because I don't want to divide 6 by 4. So I'm going to add 4x to both sides. I'm going to get y by itself. I'm going to get y is greater than 4x minus 6. Okay, I added 4x to both sides. Greater than or equal to, excuse me. So there's negative 6 here. I'm going to rise 4, run 1. And I'm going to get a couple of these points right here. You can see where they actually intersect right there. That's not what we want. It's not just where these two lines intersect. In fact, where these two lines intersect, well, it works because they're both solid lines. But sometimes they don't work where the two lines intersect because sometimes one of the lines is dotted. So anyway, everything on these two lines, where these two lines intersect actually is a solution to my system. But now what do? I'm going to shade above the green and below the blue. So I'm going to be, again, where 0, 0 tends to be. I don't know if when I write these problems, I'm aware of the fact that I'm always getting 0, 0 in there. Probably because it's the best looking shading to do. But I'm going to go ahead and shade above the green and below the blue. And this will be my final solution set right here. So all these count within my solution set. These are the good ones. which includes 0, 0. It's a good double check just to check it out. So let's try 0, 0. It should work for both. So 0 is less than or equal to 4, yes. And then 0 is greater than or equal to -6, yes. Again, all I did was I substituted 0 for x and y. I wrote out the inequality. Because it made a true statement, 0, 0 is a solution that works alongside everything else within the region. Now let's say 0 only worked for the blue thing, but not for the green. That means I am not shading in the right spot here. What would work yes for blue and no for green, I guess, would be over on this side, something like that. Okay, what else do I got to do? All right, so now I got to determine algebraic or graphically whether the following 2 points are solutions to the system. Just like how I tested 0, 0, you could substitute -1 for x and -10 for y into these and figure them out. I'll do one of them graphically and I'll do one algebraically. I'm not going to do the top, I'm not going to do this one algebraically because I don't want to substitute -1 into x in this fraction because it'll stay as a fraction. So I'm going to do this one, I'll do both of them graphically, but I'm going to show you this one graphically only. It's all that matters for me. So -1, -10. 1 left, 10 down is this point right here. That is on the line. Does on the line count? As long as it's solid, it counts. This one is solid, so it counts. This is also why plotting all these points is super important. So yes, this is a solution to this one right here. All right, in 6, 9, if I go ahead and plot this point, we might be able to get this answer. 6, 9. Okay, so that looks like a no. That looks like not a solution. I mean, it clearly does look like not a solution. Even if it was on blue, it's not a solution. You have to remember that. We have to be within this part of the region right here. So it's clearly a no. However, let's substitute it into both these in case it's the better option for you. What if I put 60, 90? Now would you know? So let's substitute 9 for y and 6 for x. And the reason why I said I'm okay with this one is because I can take 2/3 of 6, and that will be a fraction. So let's check that out. 2/3 of 6 is 4. 4 plus 4 is 8. 9 is less than or equal to 8. That is a false statement. Now, I'll tell you what. You could try and substitute, and this would actually be the preferred one. You could try and substitute 6 for x and 9 for y into this one, and then see if you get a true statement out on this one. However, once one of them is false, then the whole thing is false. It's not solutions to each equation. It says solutions to the system. And the system dictates to us that, no, that doesn't quite work for what we want here. So, no solution. We already knew that. But no solution for this point right here. Once one fails, the system fails. All right? I think I'm a little big for this page, and I think the next page requires that I move again as well. All right, so that's it for that one. Okay, here's a system of inequalities word problem. Now, if you don't know how to do these ones, you can follow me here, but the last video I did do them. This one's actually less complex than the other ones, I guess. Depending on what's kind of being asked of you. Let's check it out. Sammy is buying fish for his aquarium. Goldfish cost $20 each. It's a lot for goldfish. And guppies cost $5 each. I actually found a fish that cost $20, but when I named it on here, it was a weird name, and I think that the idea was we might not know. People who read it, I forget what it was, but people might not know that even represents a fish, because it was a weird name. So I just changed them to things that we might know. Sammy only has $100 to spend, and he does not want to buy more than 10 fish. Okay, so we're going to make two different inequalities here. The one that has to do with money, one that has to do with fish amount. Now, we're going to create that system, and we're going to let x represent the number of goldfish and y represent the number of guppies that Sammy can purchase. So when I combine the number of goldfish with the number of guppies together, we have to make sure that we do not exceed 10 fish. We have to stay within 10. That would mean less than or equal to 10. That's what that inequality states right there. Okay. The second inequality has to do with money spent. And the one with money spent is going to be like this right here. Goldfish cost $20 each. If I multiply the cost of each goldfish by the number of goldfish that I buy, that's how much money I'm spending on goldfish. $20 times X goldfish. And then guppies cost $5 each. $5 per guppy times the number of guppies right here. I only have $100 to spend. I have to make sure my number does not exceed $100. So I have to stay within 100, or I can be exactly 100. But I got to stay within this bit right here. Okay, and the last thing, and I mentioned it in the other video before, you can write two more different inequalities like these right here. These are what I call implied inequalities, and I'm sure the graph kind of dictates it for you as well. X and Y are greater than or equal to 0. All this tells me here is that I can't buy negative amounts of goldfish or negative amounts of guppies. And it's maybe possible I can buy 0 amounts of guppies or goldfish, right? I can just not go to the fish store or the pet store, and I didn't buy anything. That's less than 10 fish. That's less than $100. So that's okay, but I do want to buy fish for my aquarium, so I'm probably going to win. Anyway, the point is, I got to stay in the first quadrant when I graph. So when I do shading and when I talk about answers and stuff, I just got to make sure that I'm just within that first quadrant region. And that's all that it means. It's not required, but it's implied, and I think you can make enough sense for it and say that, yeah, the least I can buy is 0, not negative $1 billion, even though negative $1 billion is less than 0. All right, part B is actually right up here. Part B, you're going to graph the set. And I'm going to erase myself here. And I'm going to go ahead and get this graph going. So in purple, I'm going to do the x plus y is less than or equal to 10. This time I'm going to graph out a standard form. X equals 10 is my x-intercept right here. And y equals 10 is my y-intercept right here, just because there's nothing to divide on them. Now, less than or equal to does mean a solid line, so I'm going to go ahead and connect those. I don't really need arrows this time because, again, I'm limiting my thing to the first quadrant, so I'm just going to stay within the first quadrant right here. You draw arrows, it's no biggie. The implied inequalities will take care of the rest anyway. Less than or equal to 10, does that automatically mean shade below? It does if the y is positive, but if you're not sure about that, I would always test 0, 0 as a point. Does 0 plus 0 make less than or equal to 10? Yes. And if it is, then we shade on the side of 0, 0, which means I will be shading underneath. So I'm going to go ahead and shade underneath this one right here. Hold up. I'm going to shade underneath this guy right here, and that's going to be the inequality. And remember, I'm keeping those other two in mind, the two implied inequalities, and I'm shading first quadrant only. Not that I can really shade outside of the first quadrant, even though I kind of colored outside the lines there. Sorry, it's not my... I didn't learn how to color inside the lines before. I only teach math. Blue right here, same thing. I can play hide and divide. Hide and divide. Hide 5y, I get 20x equals 100. Divide by 20, I get x equals 5. So 5 is my x-intercept for this. Hide and divide here. Set x equal to 0 for the y-intercept. 5y equals 100. Divide by 5, y equals 20. So cool. It seems to be the opposite of the other guy there. So y equals 20 all the way up here. Now I'm going to connect those two. Now with a ruler, it's recommended you get a ruler for this, or it's recommended you put this in slope-intercept form. I am not. I have my line tool, so I'm going to go ahead and go straight down there. Okay. Now you can tell these lines do not intersect on an integer. And for the sake of argument for this problem, you are not going to be able to buy half a goldfish or half a guppy or anything. So even though these are solid lines here, and by the way, we're going to shade underneath here as well. 0 plus 0 is less than or equal to 100. Shade on the side of 0. Although, I don't know what I first said. Oh, although these are both solid lines here, and although solid lines should indicate solutions to the system within your shaded region, and we're going to talk about the intersected shaded region really, where these two lines intersect does not qualify as a solution. It does not qualify as a solution because it is not on an integer amount. Okay, probably shouldn't have done that blue like that, but that's okay. All right, where these two shade in total ends up being this area right here, that you can't see anything. It ends up being this area right here in green. And this is the area where Sammy is going to be buying fish from. So he doesn't have more than 10, and so he doesn't exceed $100 spent. All right? Now again, the solid lines do count if they are on integers, but if they're not, they don't. Case in point, your actual solution values, and I'm not going to do them all, but 0, 0 counts. All of these count going up this line all the way up to 10. All these points right here count, but this point of intersection does not count, and this doesn't count because it's not within green. I have to go till I find my next point of intersection, which I can't even tell if it's this or not, but it might be this guy right here. That might count. So these are values that work for how many guppies and goldfish he can purchase here and there. I'm not going to leave those up there. That's kind of whatever. In fact, I'm going to delete the green, but this is the region we can be within because that green got a little kind of eh. In fact, I'm just going to erase the ones that don't count anymore because I always tell you shade darker where you can. on the solution set, but I didn't shade darker here, so I'm just going to erase what remains. Okay, here's the region. So let's answer this question here. Sammy has two friends, April and Gino, who each suggest purchasing amounts for him. April suggests that Sammy buys 5 goldfish and 4 guppies, and Gino suggests Sammy buys 1 goldfish and 9 guppies. Whose suggestion, if either, would fit Sammy's purchasing criteria and why? Okay, first off, they both fit Sammy's purchasing criteria when it comes to number of fish. April's suggestion suggests 9 different fish, and then Gino's suggests 10 fish. And both of them are within the amount, the 10. He never spent more than 10. So both of them are correct so far. Do any of them exceed $100? You could plug them in and figure it out, but you can also check on the graph. If the whole point of this graphing was to find the shaded region of sets, let's check out April's suggestion and Gino's suggestion. 5, 4 is April's suggestion right here. Even though that was within the 10 goldfish or the 10 fish, it did not. It looks like it exceeds $100. And actually, that's pretty obvious. 5 goldfish is already $100. So once you buy a single guppy, you're past $100. That's actually $120. So April, no good. Gino, on the other hand, 1 goldfish and 9 guppies. 1 goldfish, 9 guppies is right up here. Here's Gino's suggestion. Gino's is on the line that's within that shaded region, the solid line that includes the shaded region. So Gino's works, and we can try. It looks like he'd spend, not exactly 100. The 100, I think, is part of the blue. How much would Gino suggest here? 1 goldfish is $20 plus 9 guppies, 45. That's $65. So there, I think that works out. So whose suggestion would fit Sammy's purchasing criteria? Gino's would. Gino, because the point for his suggestion is within the shaded region of the solution set. Or if we talk about it the other way, or you could say that is 10 fish, which is fine, and $65 spent. If you show your work for that and show the calculations, I think that'd be enough there. Okay, so that is the final answer of that one. Okay, so just so you're aware, and I'm going to kind of come back up in this thing here. Just so you're aware, I think that is the last problem. It's not the last problem in this whole thing, but I think that is, no, I'm going to stop you right there. There's one more problem. I remember now. Which of the following systems of inequalities would generate a no solution set right here? Circle 1 only. A, B, C, and D. The darker region, it means the intersection of any of the shading of these two. You can kind of tell they're two boundary lines. They look like they're parallel lines as well. Parallel doesn't automatically mean no solution. In fact, 3 of these 4 have solutions. They're dotted as well, but hopefully you can see those. And the darker shaded region just means the intersection of both different inequality things that are graphed. So that means this line we shaded underneath and this line was shaded underneath, so we get the intersected set. Here's an infinite number of solutions that goes down here forever. That is not no solution, that is infinite here. In fact, any of them that have dark regions, this is greater than, also is there. This is greater than the lower one and less than the above one right here. That's the intersecting region. That's an infinite number of solutions as well, so that's not the answer. This is the one where we're shading above the higher line and below the lower line. And that's the one where there's no intersecting regions at all. Nothing intersects. This is the answer to this guy right here. This is the one that has a no solution set. So there you have it. That would be number 16. Okay, so I do believe that this is the last problem when it comes to systems of equations and systems of inequalities things. The last few problems that I have that I'll go super fast on are kind of mixed review of older stuff that I've done for my students before. So if this is all you were going to look for systems of inequalities and such, then you are actually done with me. And I'm going to spend about 5 more minutes doing the last few problems that I have here. I know I've exceeded the hour, so thanks for tuning in so far, as long as you have. So I have 5 more problems to do here, and the last ones, I'll do a minute a problem. These go pretty fast. I'm not going to say very much. I'm going to solve a proportion, solve for x in a variable, talk. Okay. Number 17, solve the proportion. X over 7 equals 3 over 11. If I cross multiply here, I'm going to get 11x equals 21. And if I divide both sides by 21, I get x equals 21 over 11. It's an improper fraction, sure. It's a number I can't simplify or reduce, whatever, but it is an answer. And I'm going to take that as C. See how fast that was? By the way, I said cross multiply. Not in love with the term, but I'm in love with the shortcut of just getting this done fast. I multiplied 11 with x, 7 with 3. There's a reason I'm allowed to do it. If you want to find those things, I have 2 videos on proportions that are recorded back in August or September that you might want to check out. All right, number 18, solve for x. Let's go ahead and you have 2 options here, actually. I'll show you both. We're going to distribute the negative 3 as one of the options, and we get negative 12x plus 24. Remember, negative 3 times negative 8 equals negative 36. By the way, I wrote these problems. All of these answers can be obtained by making a mistake, such as putting minus 24. If you put minus 24, you're going to get one of the wrong answers on here, so be very careful. All right, subtract 24 from both sides. You get negative 12x equals negative 60. Another mistake people might make. If you subtract negative 24, you might accidentally make yourself negative 12. That's where you can get a wrong answer as well. So I'm tricky like that, guys. You got to be careful with me tricking you. Divide by negative 12, you get x equals 5. So that ends up being the answer, x equals 5 right here. Let me give you an alternative take on it, and that means I'm going to erase all that's right here. So pause this if you want to see it, because it's being erased in 3, 2, 1, bye. All right. Second option, I don't have to distribute. Negative 3 is multiplying by this, but if it's multiplying, that means if I want to get x by itself, I can divide by whatever's bothering the x if it's multiplying. Negative 3 is multiplying with this stuff. Let's divide both sides by negative 3. Remember, it's negative 3 times the quantity. So negative 3 goes away here, and you're just left with 4x minus 8. Everything became 3 times smaller, and negative divided by negative is a positive, so I'm going to get positive 12. If you divide by the negative, I'm sure this is one of those answer things that, again, you could land on one of the wrong answers. I think all these ones, I think every one is purposefully designed that way, just so you know. Add 8 to both sides. Divide both sides by 4. You get x equals 5. So either's appropriate, either's good. They both work. Okay, number 19. Number 19, we have find f of 3 when you're in function notation. Basically, we're going to substitute 3 for x in this whole thing. So f of 3 equals 2 to the third power minus 2 times 3 minus 3 quantity squared. Okay, so let's evaluate this. First off, 2 cubed is 8. It's not 6. Again, one of those things where something could go wrong. 2 times 3 is 6, and we're going to subtract that. Now we're going to subtract 3 squared. Now 3 squared is 9, and some people say like, oh, when you square a negative, it's positive. I'm not squaring a negative. I'm squaring a positive, and then I'm subtracting it. So make sure you don't put plus 9. You still put a minus, because that's in front of what I'm squaring, and then I square the 3, which is 9. So we're doing 8 minus 6 minus 9. That's 2 minus 9, which is negative 7. And by the way, 3 squared is 9, not 6. So negative 7 is the answer for that one. That is B. And the last one here, number 20, which equation has an x-intercept of negative 1, 0 and a y-intercept of 0, negative 4, circle 1. I have 2 different ways I can do this. One of them is kind of try both options and see which one works. Hang on, I notice I can make myself bigger. I like to do that when I can. Hey, I fit. One is kind of testing both options here, and this is where that hide and divide works out pretty well. The whole idea about the intercepts here, an x-intercept means when y is 0. So what I can do is I can substitute 0 for y and say the top equation right here. I get 4x equals negative 4. When I divide by 4, I get x equals negative 1. And that actually seems to fit with this one so far. I think this one could be correct. Let's try the other one, y-intercept, by hiding x, and we get y equals negative 4. There's nothing to divide, so you get y equals negative 4. And that seems to fit the mold with that 0, negative 4. I think A is the correct answer. And it is. In fact, B's answer, the x-intercept would be negative 4, 0, and the y-intercept would be 0, negative 1. So that's one way that I can do it. I can kind of test, I'm too big for the screen here. I can test the points, and I can see which ones kind of work, and it seems to be A. Here's another way you could do it. You could take this set itself and kind of graph it. I could graph these. 0, negative 4 is 2, 2, 2, 2 right there, and negative 1, 0 is right here. So what I'm going to do when I graph this thing is I could plot this point and kind of draw that line, because this is the line we're talking about. Now, what's that equation in slope-intercept form? That is running down 4, or falling 4 and running over 1. So down 4 over 1. So negative 4 is my slope. And then I have a slope, a y-intercept of negative 4. So y equals negative 4x minus 4. So there it is. Now, that's slope-intercept form. How do I rewrite this in standard form? I would add 4x to both sides. And what happens when you add 4x to both sides here? You get 4x plus y equals -4 right there. So that does seem to match A. Those are two different ways that I'd go ahead and look at that stuff right there. Okay. All right, last problem, A through D. Number 21, label whether each situation would represent a discrete or continuous relationship. Now, I did mention discrete and continuous a little bit earlier, and that was not, that was total coincidence that I was, and this thing comes up here. I forgot about this. Here's the one thing I want to state on continuous, because a lot of people think continuous means goes on forever. No, continuous doesn't mean goes on forever. It means it has an infinite number. It's progressively and always occurring, even within a certain interval. That means there's no gap and split in between. So remember when I talked about the number of campers at the campsite? By the way, that Guppy's goldfish problem we just talked about, can't have half a goldfish, can't have half a camper. Those are discrete relationships. Even though I connected the dots, they're discrete relationships. That means there's no fractional amounts in between the amounts that we choose. Those would be discrete. The speed of a car on Bruceville Road, it's a road here in where I live, when you're driving, you can't, and this is an impossibility, you can't go from 50 to 60 miles per hour at any point on the road without actually progressively increasing to there. Furthermore, as you're driving on the road, the speed is always measured at every increment on the road. Right? Every little bit, every little inch or microfraction stuff. This is a continuous relationship. That doesn't mean you're driving on Bruceville Road forever. That just means that while on Bruceville Road, it's forever being tracked and the speed is forever. It doesn't mean it's always changing, but it's forever being measured as you increase or decrease. That's a continuous relationship. The number of views on YouTube for Bad Guy, that's the Billie Eilish song, which is one of the more popular, most viewed videos, I guess, at least in the last year. So this thing, look, people are always going to be viewing the video unless it goes away, unless YouTube goes away, unless everyone dies. There are always going to be views going up. Now, does that mean it's continuous, that it's continually increasing? No. It's not that it continues forever. It's that the people that are viewing, the views goes from 1 to 2 to 3, to a billion and 1. There is no 1.5 billion. Technically, if these were dots, I could not connect them. All right, this is a discrete relationship because each view is its own integer amount. There's no fractional amounts of views, even though that happens forever. The number of college applications Yale receives. This could be over a forever amount of time, but again, that doesn't make it continuous. They receive an application and a second application. There's no fractional amounts within that. You either receive the application or you don't. Whether it's 100 years from now or 100 years prior to, doesn't make it continuous. This one as well is discrete. And the last one, part D here, the temperature in Mr. Kalfas' classroom, math classroom, he's another math teacher here at my school. The temperature can have small incremental fractional amounts, little decimals and different things over time, and it oscillates, and it can warm up and it can cool down, and it's not like that. It's not just hitting from 68 to 69 degrees. It went from 68 to 68.1 and 0.2, and even small fractions. It builds up to 69 degrees, and it builds up to 70, and it goes back down to 60 degrees. Okay, that's a continuous relationship. Even if it's within a single class period, that's still a continuous relationship. All right, that's continuous. Okay, so that's the final thing for it. I went to almost an hour 20, pretty long video, sorry about that. But it's for you guys to learn some things, and that's it for me. If you have any questions, please leave them down in the YouTube comment section below. And as always, even though you're seeing this at the very end of the video, I put, in case you go back to this and you want to find a specific problem or problem number, I put timestamps in the description section for the type of problem that you're looking at and the kinds of problems that you're going to see. Okay, so that's going to do it for me here. Thanks, guys. Take care. I'll talk to you probably a couple weeks, maybe a week from now,